As soon as you learn how to solve a linear equation that has a variable on one side of the equation, the next thing to do is learn how to solve linear equations that have variables on both sides. Now the main steps are going to be the same. You're going to use an LCD to get rid of any fractions, and you'll do this by multiplying all the way through both sides by that LCD. Next, if there are any kind of grouping symbols present, you're going to use the distributive property to remove all grouping symbols, if there are any. Now the next thing you'll do is look at the left-hand side and look at the right-hand side of the equation to combine like terms. We're not talking about moving things from one side to another. We're simply talking about combining like terms on the left and combining like terms on the right. And then, once you've done this, you're going to use your addition property. Now, since you have variables on both sides of the equation this time instead of just the left or the right, what's going to happen is you're going to use the addition property, but this time you're going to use it twice. You will typically not be able to use it just once. If you do things correctly and you follow the correct procedure, you can get it done using the addition property twice. Next, you'll use the multiplication property. If you've done things correctly up to this point, you will only have to use the multiplication property one time, and that should give you an answer. And then, once again, last of all, you're going to want to check your answer. So the procedure is the same, only difference being in our step number 4 here, where you use your addition property twice instead of just one time. Now let's jump in to looking at a few examples. Start off with something very straightforward and relatively easy. Let's look at x plus 4 equaling a 2x minus 7. Looking back at our steps, we see number 1 is to clear fractions, and we don't have any. Number 2 is to use the distributive property to clear out grouping symbols, and we don't have any. Number 3 is to combine like terms, and again let me point out that even though technically an x and a 2x, those are like terms, we are specifically wanting to combine like terms that are together on the left or on the right, and that we don't have. So now we're ready to use the addition property. Let's look at what we have and what needs to move. Now typically we want to end up with the x on the left hand side. So as I look at this first term, it is a variable term, and it is exactly where I want it to be, so I won't try and move it. The 4 is a constant term, and that is something I want to move. So I will subtract 4 on both the left and the right hand side, and I will get x equaling a 2x minus 11. And then we go back to the same process. The x is on the side that I want it on. The 2x is not on the side that I want it to be on. So using my addition property for the second time, I subtract 2x from both sides. I get negative 1x equaling negative 11. And at this point, I would come in, dividing both sides by negative 1. I get x equal to 11 as my final answer. And this is one we can check, and we can do it pretty easily. Putting the 11 in place of x, I get 11 plus 4, which of course is 15. Now on the other side, it was a 2x minus 7, so we'll put that in. 2 times 11 minus 7. And we get that that is correct because we have a match there. So we have verified that answer. Now let's move on to one that perhaps is a little bit more complicated. Let's take x minus 14 and set it equal to a 3 times an x plus 2. Back to our properties, we have no fractions. but I do need to use the distributive property. So distributing on the right hand side, I'm going to have a 3x plus 6. That happens when you multiply the 3 by the x and then the 3 by the 2, and that's where those come from. Now we're ready to use the addition property, and we'll again use it twice. This x is on the side that it should be on. The 14 isn't, so I'll add 14. On the left hand side we get an x equaling, and here is a 3x plus 20. Now we're going to use the addition property for the second time to get the 3x over to the side it should be on. I will subtract 3x, subtract 3x. I get negative 2x equaling 20. I don't want the negative, and neither do I want the 2, so I divide both away, and I'll get x equaling a negative 10, which we could again verify on the calculator. And let's do one more verification before we give up on doing those for now. Let's take a negative 10, and that was a minus 14, so we'll go ahead and put in the minus 14, and that gives us negative 24. So we are seeing negative 24 on the left. And let's try the right hand side. We'll do a 3 times the negative 10, and what was it, a plus 2? Yes, negative 10 plus 2. And when you close the parentheses, again, we see that our result was correct. That verifies our result. So we can clear that out and go back to our examples. Let's look at another one. Once again, raising the bar a little bit on difficulty. Let's look at a 3 times a y minus 1, and outside of that we're going to put a plus 9, equaling an 8y plus a 6 minus a 5y. Again, as far as the order in which things should be done, let's see. There are no fractions, and right here we need to use the distributive property. So I will distribute once and then twice, get a 3y minus 3 plus 9, equaling an 8y plus 6 minus 5y. At this point we need to combine our like terms. A 3y minus 3 plus 9, the minus 3 and the plus 9 go together because they are both constant, and you get a plus 6. 8y minus the 5y will give you a 3y plus 6. So we have combined our like terms, and at this point you may be noticing there's something going on with this equation. If you're not sure what's going on yet, let's keep going. The next step would be to move the 6 to the other side. So I'll subtract 6 from both sides, and you get a 3y equaling a 3y. And again, something looks strange here. I'm going to move this 3y over by subtracting, and what I get is a 0 equals 0, which is a result that's slightly different than what we've seen in some of these other problems. You notice that the variable has completely disappeared, and that hasn't happened before. If your variable disappears like this, then what you've run into is one of two special cases. Most of the time you get one result, an 11, a negative 10, for example. This time, when the variable disappeared, I was left with a true statement. 0 does in fact equal 0. So this means that our solution set is going to be the set of all real numbers. That means that any number you pick, if you put it in place of y in the original question, it'll always work. And that can actually happen. That's not uncommon for something like that to happen. As a matter of fact, there are other situations in which we get no solution. Now, when you get an 11 or a negative 10 or something of that nature, that's called conditional. What we just saw here with this 0 equals 0 is actually called an identity. on there? Identity. Alright? And we can also get what's known as a contradiction. And a contradiction, let's look at an example of what could turn out to be a contradiction. If you had something like negative 3x plus 4 plus 5x equaling 4x minus 2x plus 5, and we start combining like terms, we would get a 2x plus 4 equaling a 2x plus 5, and when we tried to move the 4 over, we would subtract 4. We will get a 2x equaling a 2x plus 1, and when we subtract off the 2x, we get a 0 equals 1. And this is what we refer to as a contradiction. And contradiction means no solution is what that implies. So again, when the variable disappears totally from the problem, you've got one of these two situations. If it's a true statement that's left behind, like 0 equals 0, 5 equals 5, negative 4 equals negative 4, your solution set is all real numbers, and that's called an identity. The other extreme, if you get a false statement left behind, that's called a contradiction, and that implies that there is no solution. Now let's go on to another problem or two. Let's look at a minus 7 over 3 equaling an a plus 5 over 2 minus 7a minus 1 over 6. With this type of problem, because the numerators are more complicated than before, they're actually binomials, I think it is an excellent idea to put parentheses in whether the textbook shows them or not. We look at these three denominators, and again our step number 1 is going to be, if there are fractions, clear them out using the LCD. Our denominators are 3, 2, and 6. That means we're going to use an LCD of 6. So we're going to multiply 1, 2, 3 times by that LCD, and we want to simplify. 6 over 3 is 2. 6 over 2 is 3. And 6 over 6 is a 1. Now we can start distributing. This becomes a 2a minus 14 equaling a 3a plus 15 minus, and watch your minus signs and your negatives very carefully, minus 7a, and it becomes a plus 1 when the minus sign gets distributed. Combining like terms is going to be necessary on the right hand side. 3a minus 7a is a negative 4a, and a 15 and a 1 is a 16. So our like terms are combined, and now we use our addition property twice. First time I add 14. I get 2a equaling negative 4a plus 30. Then I add 4a, and I get 6a equaling 30. Let's come up here and finish this. 6a equaling 30. I divide off the 6, and there's my 5. Alright, so there are a few examples of solving a linear equation when you have variables on both sides. Again, it is just like solving linear equations when you have variables on one side, main difference being you have to use the addition property twice. Other than that, it is the same process.